So as I've said we were going to do at some point, I'm going to show you how these work on Desmos. It is really just going to be a whole lot easier, obviously. The calculator does most of the work for you. All right, so let's start with this one. This one's asking for the value of x plus y in the systems of equations below. So I got y equals 2x plus 5, and I got y equals negative 3x minus 5. So all you need to do is you'll go over to Desmos, or when you're taking the actual EOG or a check-in, you click the little calculator for the graphing calculator, and you're going to put in, like we saw, y equals 2x plus 5, and y equals negative 3x minus 5. Okay? And it graphs the two lines. Your answer uses the point where they cross, just like we've done with equations before. So when we're looking for where they cross, we've got negative 2 and positive 1. Yo, which one's the x value, which one's the y value? X value is negative 2, y value is 1. It goes x first, then y. All right? For this problem, it doesn't make a huge difference which one's which, because it asks for x plus y, so you're adding them together. For other ones, sometimes they ask you for just x, sometimes they ask you for just y, sometimes they ask you for the ordered pair. So if we do for y, we're adding them together, because that's what this says to do, right? So signs are different. When the signs are different, we subtract. We use the sign of the bigger number. So that would be our answer for this one. Okay? That's it. Easy enough, right? You put it into Desmos. Desmos finds where they cross. Use your x and y from where they cross. Okay? Any questions on that one? All right, so let's get a little more complicated. Go ahead and give this one a try. You got y equals 2x plus 3, and you got 3x plus 2y equals 27.
We put y equals u. I can't find a green bar.
All right, Aubrey, what you got? No? This one's not asking to add them. Try Aubrey. No. Nick? No? Keller? 3-9. Go. I didn't put the question on this one. When it's giving you the equations, if it's looking for like where they cross a point of intersection, you want to find the ordered pair, okay? You only add them if it specifically asks you to add. It's only X or only Y if it's specifically asking for those. Otherwise, basically, you're looking for your ordered pair. So just like the other one, we take this, we put it into Desmos. So we got our 2x plus 3 and 3x plus 2y equals 27. When we go to Desmos, we just put them in exactly like they looked. worked. You had y equals 2x plus 3, and we got 3x plus 2y equals 27. All right. Y'all, you can tell they're crossing somewhere up here on my screen. It might have been on y'all's screen. Worst case, you hit the little minus, you got to zoom out a little bit, right? Sometimes you got to do these on these, especially when we do problems with a higher number. Then, like I said, your answer is the ordered pair. Ordered pair is 3, 9. If we had to add them together, then you would add them together, you get 12. If it was just x, you get 3. If it was just y, it'd be 9. Just, pay attention to kind of what it's asking for. Any questions on that one? All right, so fairly easy, right? All right, so this one, we got line A passes through the point 2, 5, and 4, 13. Line B is y equals x plus 6. Okay? So we're looking for the point of intersection between the two lines. That's what we're looking for on all these. We're looking for the ordered pair, okay? So I'm going to put the second equation in first because it's already got the equation, okay? That's line B. So we got y equals x plus 6. Everybody's good with that part, right? That's that's the easy part. Once you have that, we need to get those ordered pairs in. So to do that, we press the plus sign, and you want a table. All right. Our x value for the first one was 2, y value 5. So I put 2, 5 in. For the second one, we had 4, 13. Okay? So what that does is that gives us a line, and it gives us those 2 points. Y'all, if you look, if we're looking at, where our dots are, you can kind of tell where they cross, right? If you took like a piece of paper or something and put it along the edge, you could probably see where they intersect. And you could do it that way. The other way you can do this is you can get a line drawn. Once you have 2 ordered pairs, Desmos will draw a line for you. All right, so write this on your board. You are going to put, or you are going to type in y1, and then you press shift, and you're pressing the button next to a 1 to get that little squiggle line. And then you're going to type in m x1 plus b. And y'all see what that did? It connected the dots for me, right? And look, it's crossing at 3, 9. Everybody kind of follow on that? I'm going to write that up on the board again in just a second, so in case you didn't get that. But you put it on the table. Y'all see on my table how at the top it says x1, y1? That's why we use y1, x1 on our equation. If for any reason something happens and it says something different than x1 or y1, then you have to change that number on those, okay? So if it said x2 and y2 on the table, you'd have to use y2 and x2 in your equation. Does that make sense?
So it's always y. It's never changes.
Well, we want the equation. So our basic equation for a linear function is our slope-intercept form, the y equals mx plus b. And that's what we're doing. We're putting the y, but instead of y, we need to specify that it's y1. Instead of the equal sign, we're using that little squiggle line up there next to the 1. So you got to press shift and then that button to the left of the 1. Okay? And then you put mx1 plus b. All right, so when you do that also, what that tells you, it tells you a little bit like, it tells you what m equals, that's your slope. It tells you what b equals, that's your y-intercept. So that's a way you can get a linear function from some points too, okay? Everybody got that written down? We're going to hopefully use that enough that you kind of get that memorized, okay? So it's y1, our little squiggle line, mx1 plus b. The reason we use the little squiggle line there is because it's not always going to be an exact line. We'll get to some stuff later this year where it's like making an approximate, like you'll have a bunch of dots kind of scattered around. It's actually called a scatter plot, and we'll have to get a line for that so it doesn't like fit exactly,